balloon with mass m is descending down with an acceleration where a is less than g. How much mass should it be removed from it so that it starts moving up with an acceleration a? So we will discuss this question in two different parts. Okay, so let's discuss the first part. So what is the first case? It is given that the mass of the balloon is m, right? Mass of the balloon is m. Mass of the balloon is m, and it is descending down, right? So the net direction of motion is acting downwards. Okay. How much mass should be removed? Okay. So let us discuss only the first part now. So, assuming this to be the balloon with mass m, what are the various forces acting on it? See, the first force acting on it would definitely be the weight, which is mass into acceleration to gravity, right? Now we need to understand that since it is a balloon, it will definitely experience the force of buoyancy, right? So there are two forces acting on this: force of buoyancy and the weight. Now, what is the net direction? See, the object is descending downwards, right? It is descending downwards with acceleration a. Okay. So all those forces, my bad, all those forces which are along the direction of motion, irrespective of the number, they should be taken as positive. So what I'll do, I'll consider this as positive mg. All those forces which are against the direction of net motion will be taken as negative. So I'll take it as negative fp. Okay. Now, see, as we did in the previous problem, right? This question, so if you have to understand this, okay, let me explain that part also. So see, this is the balloon here, right? And this balloon has movement only towards, okay, so it was here. It has movement only in the y direction. Either it is descending downwards or it is descending upwards. Either it is descending downwards or it is ascending upwards. So the movement is either top or bottom. It is neither moving to the left nor to the right. So there is no movement along the positive x or the positive negative x. There is movement along either positive y or negative y. So what is the key point? No movement along the positive x nor the negative x, right? Okay. So we can say that since there is no motion, along which direction? Since there is no motion along the x direction. So if there is no motion, it simply means that velocity along x direction is equal to 0. See, if velocity along x direction is equal to 0, what is acceleration along x direction? That is also equal to 0. If velocity along x direction is equal to 0, if acceleration along x direction is equal to 0, what is mass into acceleration on x direction? That would also be equal to 0. Therefore, what is ma? Ma is fx, right? Ma is f, and therefore max is fx, and therefore fx is also equal to 0, right? Now, what do we have to find out? Is fy. So what is the equation for fy? Fy would be m into ay, right? M into ay. Now, since there is no fx here, since there is no ax here, since ax is also equal to 0, I'll take ay as a, so get it as m into a. Okay. Now, what is fy? Fy denotes the sum of forces, what? Sum of forces acting along the, which direction? Acting along the y direction. Right? Now, how many forces are there acting on the y direction? We have one force Fb and the other force mg. And how will you write the sum here? You will write this as positive mg, right? Positive mg over here minus the FB, right? Minus FB. And what would this be equal to? This would be equal to M into A, right? So this is one part of the story. What is the second part? Mass is removed and it starts moving upward with an acceleration. So let us discuss that part. So now what we have is there was a balloon with mass m, okay? Let's assume that some amount of mass is removed from it. So say it's like this now, okay? And the removed part weighs m dash. So there was m. What has been removed? M dash has been removed. In which case, what is the mass of the leftover block? It would be m minus m dash. Okay. Now, if this is the case, what are the forces acting on it? See, we know that the very first force acting on this body would be definitely the weight, and the weight being m minus m dash into g, right? And what is the buoyancy force acting here? It would be FB. But this time you need to understand that the moving up with it's moving up with an acceleration, right? So the net direction of motion is acting upwards. And when net direction of motion is acting upwards, what do? You mark all those forces along that direction, in which in this case is upwards, as positive. So all those forces which are along the up direction will be considered as positive. So we'll mark this as positive. And simultaneously, when all those forces along the direction of motion are considered as positive, all those forces which are against the direction of motion here would be considered to be considered to be negative. So we'll put a negative sign here. Okay. Now again, there is no direction, there is no motion along the x direction. So we have ax is equal to, okay, therefore vx is equal to 0, and therefore ax is equal to 0, and therefore we have m into ax is equal to 0, and therefore fx is equal to 0. So the only set of forces here acting here would be along the y direction, and therefore we need to find out fy, and we have the formula sigma fy is equal to m into ay. Now instead of m here, we actually have m minus m dash. So this m minus m dash into ay, and since there is only one component of ay, there's only one component of acceleration along the y, and since ax is equal to 0, I can write this as m minus m dash into a. Okay. Now, if you were to ask me how does that come, so it's very simple. What is a is equal to? A is equal to root of ax square plus ay square. Ax square is 0, so this is equal to root of ay square. This is equal to ay. Therefore, I can write that a is equal to ay. That's the logic. Okay. Right. So we have sigma fy is equal to m minus m dash into a. Yes, that's there. So what is sigma fy now? Okay. So we have one force fb along the positive direction, right? So we can write that as positive fb, and then we have minus this force over here, minus m dash into g is equal to m minus m dash into a. Okay. So if we write this further, what we get is fb minus mg minus into minus plus m dash g is equal to ma minus m dash a. Okay. Now let us bring these two equations together. Which ones? This one. This is the first equation. Let us bring this one also. This is the second equation. Let me erase out the things that are not required. Okay. Now what we'll do is, we will, as in the case of every problem here, what we'll do is we'll add these two equations. So what do we get? What we get is fb minus mg plus m dash g plus mg minus fb is equal to ma minus m dash a plus ma, right? Now see, which all terms will cancel off? fb minus fb is 0, right? Minus mg plus mg is 0. And ma plus ma is equal to ma plus ma is 2ma minus m dash a, right? And if we bring this ma dash to the LHS, what we get is m dash g plus m dash a is equal to 2ma, right? And therefore, if you take m dash common from here, what you get is g plus a is equal to 2ma, and therefore m dash is equal to 2ma the whole upon g plus a, which gives us the correct option as option A. Okay, so I'll just summarize the entire solution one more time. So where did we start? We took the first case, right? What was the balloon doing? The balloon was descending downwards. So net direction is towards negative y. It is acting downwards. So all those forces acting along negative will be acting downwards will be taken as positive. Weight is acting downwards, therefore it is positive. Buoyancy is acting upwards, therefore it is negative. Now the other case, mass m dash is removed, remaining mass is m minus m dash. Net direction is acting upwards. All forces acting upwards should be considered as positive. Therefore, buoyancy is considered to be positive. All those forces acting against this is mg. It is considered as negative. Free body diagram, one equation, second equation, and equations. What you get is m dash is equal to ma by g plus a. Okay. So, well, I think this was question. Okay, it's here, right? CBSE AIPMT 2014. So there was a switchover between NEET and AIPMT back again. So that was the only year, I would say, after 2013 that the exam was conducted as AIPMT. Later on, it was merged with AIMS and with NEET. So I would say a really good question, for definitely above the standard of a typical state level entrance exam, and definitely not as high as AIMS. When I say this, I'm referring to the year of 2014. After that, there was after 2017 there were dramatical changes in the pattern, but I would say this was a really good question. So yes, that's what I have to say about the question here. Let's move on to the next question.